Hello everyone, welcome to my presentation on the Shed Frame project. My name is Lucia Lara, and I'm currently enrolled in Engineering Architecture 2 at Joliet Central High School. The Shed Frame project involves the design and construction of a framework of a miniature shed model. The goal of this project is to construct a shed that abides by the legal Joliet requirements for a shed construction. The building requirements and constraints for a shed in the city of Joliet, Illinois are as follows. A shed permit, which you can see in the infographic on the right, is required prior to the construction of any shed, no matter the type. These permits cost you around $65 and will take around 15 business days to get approved. The shed cannot be more than 50 feet tall and must be located less than 6 feet from the house. And something important to take notice of in the infographic is that sheds are prohibited from being built in front yards. The project began inside Autodesk AutoCAD. I had to draw the side walls and its studs. The front and rear walls contain a sill, a header, and multiple cripple studs. And lastly, I had to draw the trusses containing web members with the same pitch value. These drawings would become an integral part of the shed construction process. Once I finished all of the CAD drawings, I got to printing them on a B-sides paper. Then I cut a piece of cardboard with dimensions 11 and a quarter by 17 and a quarter to accommodate for the 11 by 17 inch paper that the CAD drawings were printed on. The purpose of printing CAD drawings were to give me an easier time finding out the dimensions of the studs and their location compared to other features at a 1:1 scale. To finalize preparations of the construction, I wrapped the cardboard in a wax paper to ensure that the glue I will be using to hold the pieces together wouldn't stick to the paper underneath. I began the construction by grabbing a long, thin piece of wood and aligning it with the sole plate. I took a pencil and marked exactly where I needed to cut it. I did this for all the pieces of the sidewalls. Once I was finished cutting all the necessary pieces, I began to attach them to the cardboard by using two pins and create a cross that would hold the pieces perfectly still. I did this for every piece, avoiding to use pins around the edges and where pieces touched. Once the pieces were secured, I got a bottle of glue and a cotton swab and began to glue the pieces together. I did this on both sides. Now that the pieces were glued together, I took the pieces out of the cardboard and switched the side walls paper print for the front and rear walls paper print. Moving on to the front and rear walls, I did the exact same thing as I did with the side walls. I cut the pieces accordingly to the size in the printed out CAD drawings and began to attach them to the cardboard by crossing them with pins. The only features that stood out were the header, the sill, and the cripple studs. I had to use a special kind of wood for the header, a much thicker kind of wood. I cut the two headers and attached them to a normal sized wood that I was familiar using of the same length to the header, creating the support that held the header up, the window, and the door. In order to create the sill and the cripple studs, I used one of my faulty unusable stud pieces from earlier and cut them into smaller pieces that matched the length found in the CAD drawing. After everything was pinned together, I grabbed the glue and the cotton swab and began to glue the pieces together on both sides, similar to the side walls. The trusses were more the same. The only difference was that this time I struggled with the web members because of their unusual shape. But after following more of the same process, I aligned pieces of wood in the CAD truss print drawing and marked it and cut it soon afterwards, and finally glued them together with glue and a swab. I would like to state that unlike the front and rear walls or the side walls, I had to make 6 trusses opposed to 2. Now that all the walls and trusses were finished, it was time to assemble all the parts together. To prepare on how exactly I was going to assemble the shed together, I gave myself an idea on how it was supposed to look by having a dry assembly. I propped up the walls using pins to hold up the walls. After getting a feel of how the walls were supposed to be aligned, I had to find a base for my shed. Using the 11 and a quarter by 17 and a quarter inch cardboard piece from earlier, I cut it to a small 11 by 11 piece of cardboard to serve as my base for my shed. In order to begin gluing my walls together, I had to find a way to make sure that the walls stood up properly and couldn't move when I applied the glue. Because tape was nowhere to be found, I had to use pins to hold up the walls and stop them from moving at the slightest touch. I used several pins at each corner of the wall, making sure that every wall was connected and stable enough to where it wouldn't unexpectedly fall. With everything secured, I used two long pieces of wood to serve as my top plate. I used this top plate to glue the side walls to the front and rear walls first. With all the walls now properly glued together, I finished the top plate by using two smaller pieces of wood and gluing them to the top of the front and rear walls. I turned the shed upside down to make sure that there weren't any gaps in the wake of the top plate and the walls. The finished top plate and the walls were properly glued together and allowed me to begin on adding the six trusses. I started by adding the truss on both ends of the shed, one in the front wall and one in the rear wall. Then I grabbed a ruler and measured the space between the two trusses and divided the number by the number of trusses I had left. I used the quotient to find just how far each truss was from one another to be properly spaced out. Marking the locations where the trusses would go, adding the trusses and gluing them onto the plate was easy enough. With the shed finally being built, the only step for me to do was to glue the shed onto the base. I tried my best to align the shed to the center of the cardboard piece, and once I was happy enough with the placement, I glued the shed onto the base. Now, my shed was not perfect by any means, and I would definitely go back and construct it differently. Firstly, I would measure the length of the pieces I was cutting to make sure that the length was consistent. Every one of my walls had one or two studs that were smaller than the rest and messed up the structural integrity of the wall. By measuring the piece with a ruler, I would be able to assure that every piece was X inches long with no discrepancies. The next big thing I would do differently was come in freshman hour or advisory to work on the shed. For those who don't know, freshman hour is an hour earlier in the morning where the classes for upperclassmen haven't started yet, allowing for extra time on projects and homework if you need it. An issue on my shed was that I was pretty rushed at the end, and if I had more time, it would have definitely turned out neater. Something small I would do differently was use a pencil to mark my cuts. During the making the trusses, I didn't have a pencil on me and had to use a pen instead. The issue with the pen was that I couldn't erase the mark after I was done with the cut, meaning the trusses had pen ink on them, and if I had to use a pencil, my trusses would have looked far better. Well, on the subject of trusses, I would completely redo my trusses. My biggest issue on the truss was that I could never get the bottom cord length correctly. I would always make my bottom cord too small and it would throw off the rest of the truss. Another issue I had was the tip of the trusses. No matter how I cut my pieces, I was never able to get the tips of the trusses to touch properly. But putting my grievances aside, I had a lot of fun making the shed. I liked how straightforward the project was. While it didn't leave room for any personalization or experimentation, sometimes you need those projects that don't require a lot of thinking. The thing I liked most about this project was how I was able to utilize AutoCAD in this project. AutoCAD is usually utilized in a project for laser cutting, but like the CO2 Dragster project, AutoCAD was used to make drawings that were able to be used as a reference. Well, nothing extraordinary, it was a unique way to use AutoCAD. That is my shared presentation. Thank you for your time.